I start with that letter F like this. You can see my letter F. So to correspond, it means in this case, if I've got that particular angle, let's say I've got this line AB, now there's a condition, and CD, there is a condition for corresponding angles. First of all, look for parallel lines. You must look for those signs. It means AB is what? AB is parallel to what? To AB is parallel to CD. So AB must be parallel to what? CD. That's the first condition that you need to look for. And then this line, if ever we have got XY, we call it a transverse line. So they just call it a transverse line. So this particular transverse line, when it cuts across parallel lines AB, now we come up with corresponding angles. Look at them. That angle will be equal to that angle. That's where the correspondence comes into play. Hello, our most valued student. My name is Confident. Welcome to our lesson on Introduction to Euclidean Geometry, and this lesson is very suitable for those of you who are doing grade 10 and also a good foundation if you are already in grade 11 but you did not understand the basics. So I'm just going to spend 24 minutes. I'll try to make it exactly 24 minutes whereby I'm going to lay very important foundation, which I will always encourage you to go back to this foundation every time you are struggling with some of the concepts, especially when you are introducing Euclidean geometry. Now remember guys, subscribe to this channel. I know most of you are watching this channel. Just go and subscribe and ensure that the notification bell is turned on so that every time I load a video, YouTube is going to notify you. So go on and subscribe right now. So let's begin the lesson. As I said, I'm going to introduce in 24 minutes at most, just to see if ever you can bring in some, you can remember some concepts here. The first one, he says the three properties of lines. So let's investigate the three properties of lines. Now, when we're talking about lines here, we are talking about the first one is a straight line. So if I bring to you a straight line, and let's call this line, let me bring it a bit down. So we have got a straight line, and then let's call this line our line AB. So we've got A and B. Now if this is the center of the line, what you need to know is that if I start from this point and I go all the way to the other point, that angle is equal to 180 degrees. Always remember that. That angle is equal to 180 degrees. Now, if I cut that line like this, meaning I'm separating this line into two angles, as you can see, let me put 180 at the bottom. So you see now I've got two angles. The first one, let me call it, if this is point C, out of interest sake, let's call this point, let me bring this down a bit. Let's call this point C here. So if this is point C, we will call this one 1 and 2. Now what you'll need to remember when we're talking about the properties of lines, we are saying angles in a straight line are equal to 180, or if you look at 1 and 2, 1 and 2, they've got a special name. They are said to be supplementary or supplementary. What does it mean? If they're saying it's supplementary, it means they add up to 180 degrees. Why? Because a supplementary angle, they form a straight line. Meaning, if I say C1 plus C2, what must I get? I must get 180 degrees because they form a straight line. Don't forget. So which means if I say C1 plus C2 is equal to 180 degrees, it means AB is a what? It means AB is a straight line. So don't forget that, the first part. The second part or property that you need to know whenever you are dealing with a line, let's say I've got my line, like I've got different lines here. I'm just going to draw different lines and different lines and different lines. There is something special about that. Let's say here I've got in the meeting point, we will call it point A. That point will refer to as point A. There's something that you need to know about these angles in a point. When you add that angle, let's call it 1, and you add that angle, let's call it 2. You add that angle, let's call it 3, and you add that angle, let's call it 4. Meaning, if I say angle, I'll say A1 plus A2 plus A3 plus A4. So what we call this, these are angles in a point. They must give you 360 degrees. Don't forget that. We call these the angles at a point. They must add up to what? They need to add up to 360 degrees. And then let's look at the last property of lines. If I've got two lines, for example, let's say I've got line here, it's AB, right? It's a straight line, and then I get another line, we'll call it line BC, like that. So I mean it's line C. Already we've got AB and then C and D. So we've got these two straight lines. Something interesting, if I've got that angle, let's call it 1, let's call it 2, let's call it 3, let's call it 4. So we know already angles at a point. Remember I told you they add up to what? They add up to 360. But something is more interesting here. If I look at that line, I mean that angle, and I look at this angle, now something is interesting. Let's say this point was point E, that meeting point. So you'll see that E1 or angle E1 is equal to angle E3. What do we call them? We call them vertically opposite angles. Don't forget that. They are called vertically opposite angles. So what do we say? We say vertically opposite angles are equal. Meaning, if E1 is equal to E3, what can you see again? E2 is equal to what? Is equal to E4. We call them vertically opposite angles. So there are three concepts in a line that you need to know. The first one is angles in a straight line. The second one is angles at a point that add up to what? 360. And then the fourth one is, the third one is vertically opposite angles being equal. So that's the first part. Let's go to the corresponding angles. What we mean by corresponding angles, when you are dealing with corresponding angles, I want you to always try to look for that letter F. That's what is actually shaped like an F letter. So if we're dealing with corresponding angles, the first one that I do, I start with that letter F like this. You can see my letter F. So to correspond, it means in this case, if I've got that particular angle, let's say I've got this line AB, now there's a condition, and CD, there is a condition for corresponding angles. First of all, look for parallel lines. You must look for those signs. It means AB is what? AB is parallel to what? To AB is parallel to CD. So AB must be parallel to what? CD. That's the first condition that you need to look for. And then this line, if ever we've got XY, we call it a transverse line. So they just call it a transverse line. So this particular transverse line, when it cuts across parallel lines AB, now we come up with corresponding angles. Look at them. That angle will be equal to that angle. That's where the correspondence comes into play. But remember, I said you must always look for the what? You must look for the F. Now, another way to look for the F is I can have the same line similarly, but look at this one. I'm still dealing with my F shape, but in this case, you can see where is the F. Look at this. My F is this version that is facing this direction, facing that direction, and that facing that direction. You see that it's an F that is inverted. We can also look for what? Corresponding angles. So which one is the corresponding angle? That angle is equal to that angle. You see that? That is corresponding. I can actually choose another F. Just look at the F that I'm going to choose now. On the same diagram, I can have that one with that one with that one. And then I can also have a corresponding angle. That angle is equal to that angle. Do you see how I'm trying to locate the F angle? I can even come here and focus on my what? On my F. Look at this one. I can focus on that, and focus on that. Do you see the F that I'm having? And I can have a corresponding angle. That angle is equal to that angle. So it depends how you want to bring it about. You can have different scenarios, but the first part that you need to identify is parallel lines. As you can see here, I didn't identify. I need to have that and that. That's the first condition, so that you've got AB being parallel to CD. Then you can have a situation of corresponding angles. And then what did I say you must look for? You must look for the letter F. It can be like that. It can be like that. It can be like these. Just different ways of getting your F. Or it can be like that. So depends how you're forming your F, but always look for the shape for F. Corresponding angles. So what do we say? We are saying corresponding angles are equal. So if, for example, I had here this point here was 1 and this point was 2, so I had X here, I had Y actually here, so you're going to say X1 is equal to Y2. Y, you're going to say corresponding, you call it corresponding angles. Then there's the next condition, you're going to say AB is parallel to CD. Are you getting that? That's the explanation that you're going to give for that. So let's move on. After corresponding angles is alternate angles. What do we mean when we're saying something is alternate? When we're talking about alternate angles, we are going to look for a special letter, which is letter Z. Or you are going to look for a special letter, which is letter N. That's what you're looking for. So let's look into that. Let's start with the letter Z. If I give you a letter like that, and like that, do you see that I've got my letter in a way is like letter Z? Again, special condition, you've got AB, and with AB you have got what? You have got let's call it C and D. There must be a special condition. AB must be parallel to CD. So you're going to write AB is parallel to CD. If that is the case, then you can come up with an alternate angle, provided there is a line which is cutting across. It can be a long line like this. Doesn't matter, it can extend, but you can see your Z shape. If I can draw my Z shape here, it will look like this. This is my Z from there to there and to there. You see the Z. Now, what does it mean about the Z shape? It means alternate angles. That angle is equal to that angle. That's the first one that you need to remember. Don't forget that. So I can actually call this one here, let's call this 1 and call this 2. So if this is x and this is y, so you're going to say x1 is equal to angle y2, and then the reason you're going to give is alternate angles. Now, what makes it to be alternate angles? AB is parallel to CD. That's the reason that you're going to be bringing in. So that's the first case of alternate angles. What about the N shape? You can see if I change this Z, I can actually come up with the letter N. So it will look like this. If I'm now coming up with the letter N, it will look like that, it will look like that, and it will look like that. You see the letter N. But now if I'm to draw in reality, that letter, it doesn't have to become just a simplified N, but you can see the letter N in that. Look at this. There is my N, like that, and like that. You can still find alternate angles. Where is it? That angle is equal to that angle. So this is the simplified version of the letter N. But now sometimes it can come a little bit, still the same Z shape, but now it might look a little bit different. Look at this now. If I've got my lines like that, remember I said I'm forming a Z shape, and if I can draw that Z shape, it's that one here, like this, and like this. And then what is the condition? Don't forget, these lines must be parallel. See, so if I've got my AB here and I've got my CD, so now what condition do I have? Look at the part that you might actually still get so that you can see corresponding angles. So with this set, you can still come also with another kind of a set. Just look at this one. If I move from here, and move from here. Now look at what I'm forming now. That angle is equal to that particular angle. And previously we had said this angle was equal to that angle. Seeing that. Even if I'm dealing with my N shape, I can do my N shape like this, to say I have a line, and remember the condition, parallel lines. If it's parallel, now look at the kind of the N that I'm gonna have in this case. I can have that, and that, meaning that angle and that angle, they form like a kind of an N. They are alternate also. Why? Because we said this angle was alternate to that angle. So these are the alternate angles that you can bring about. Don't forget that. With alternate angles, let's continue, comes co-interior angles. And when you're dealing with co-interior angles, the letter that you need to focus on is the letter U. So again, we're dealing with special parallel lines. If I have got my line like that, and then I got a line that cuts like that, and then what do I have? It doesn't have to be horizontal straight, but like a U shape in a way, and I can come up with my U shape. It doesn't have to be a perfect U, but you can see there is my U. And what is the condition? The condition is these lines need to be parallel. See that? Meaning if I've got my AB here and I've got my CD here, then when you talk about co-interior, look at the angles I'm going to form. The inner angles. I've got that angle and I've got that angle. We've got a special property here. We are saying the co-interior angles are supplementary or supplementary. So supplementary, and you remember what does supplementary means? They add up to what? 180 degrees. So if I had here 1 and 2, so I had X and I've got this point being Y, it means angle x1 plus angle y2, they must add up to 180 degrees. Why? Because actually the reason is supplementary angles. Also the condition is AB being parallel. That's the condition to what? AB is parallel to CD. Alright, then let's look at different types of triangles: the acute, the obtuse, and the right angle triangle. So if they say to you, what does an acute triangle look like? An acute triangle is looking like this. This is a simple acute triangle. So let's say I've got this triangle A, B, C. We call this triangle acute. Now the question is, what makes it to be acute? That angle, and that angle. So all the angles are smaller than 90 degrees. Are smaller than 90 degrees, meaning they're acute. Remember, acute means less than 90 degrees. What about obtuse? Now an obtuse triangle is a little bit different, whereby you can have a triangle like this, and like that. Then whereby this becomes your A, your B, and your C. Now look at this angle. Now angle B must be greater than 90 degrees. If it's bigger than 90 degrees, we call this an obtuse angle, a triangle. Obtuse triangle. You know why? Because of that B. Well, A and C are still acute, but whenever there is an angle bigger than 90 degrees, we call that an obtuse triangle. And then from that, we also have a right angle triangle. Now a right angle triangle is a common triangle that we've dealt with. It looks like this. Let me use a different marker. A right angle triangle looks like this. Alright, so what makes it right angle is that special 90 degrees. We call that a right angle triangle. So if I've got A, B, and C, so B, angle B must be equal to what? Must be equal to 90 degrees. But now you know the special property of that. Pythagoras theorem now is active, whereby AC squared is equal to BC squared plus AB squared. Remember, but now if you still remember the way you name triangles, that side is side small b, and this side is small c, and this side is small a, such that b squared is equal to a squared plus c squared. This is the theorem of Pythagoras. You see it whenever you're dealing with such. Now focus again on the three types of triangles further: the scalene, the isosceles, and the equilateral triangle. Now if I'm to draw a scalene triangle, it looks like this. You know, it's a triangle. If it's A, B, C, this is a triangle with all the sides different. You know, they are not equal. Each side AB is not equal to AC, is not equal to BC. So this is a triangle with three different sides. That's a scalene triangle. What about an isosceles triangle? An isosceles triangle will look like this. You have that line, you have that line, and that particular triangle, if I call it my A, my B, and my C, something is special with an isosceles triangle. It means if these two sides, AB, is equal to AC, then you have got an isosceles triangle. An isosceles triangle is a triangle which has got two equal sides, or something is even special about this kind of triangle. Those base angles, angle B is also equal to angle C. So now what does it mean? Whenever you're given an isosceles triangle, these are opposite sides, angle equal opposite sides. So sometimes here they write, if B is equal to C, we are saying angle B is equal to angle C. What is the reason? We are saying angles opposite equal sides. What does it mean? these two angles, this angle is opposite that angle, this angle is opposite that side. So these angles are opposite equal sides. AB is equal to AC. So when you're writing it, you are going to say angle B is equal to angle C. Now, reason being, AB is equal to AC and angles opposite equal sides. Or sometimes you can state that side AB is equal to side AC because angle B is equal to angle C. Then here you are going to say sides, because you are starting with sides opposite equal angles, you see. So that is what? That is an isosceles triangle. Now let us look at an equilateral triangle. It's also very important. An equilateral triangle, from the word equal, you are getting something like this. It's equilateral. If I've got my A, my B, and my C, look at this. AB is equal to AC, which is equal to BC. So AB is equal to AC, which is equal to BC. What do you mean? It's an equilateral triangle. All the three sides are equal. Also, it's very special. Now, each angle here, we're going to talk about this now, not long. Each angle is equal to 60 degrees plus 60 degrees plus 60 degrees. We're going to talk about this shortly. All right. Angles in a triangle, that's where I'm coming into now. Now, when I talk about angles in a triangle, if I've got a triangle, let's start with the equilateral triangle, which I just did. So if I've got a triangle like this called ABC, and then I know that AB is equal to AC is equal to BC. Now they say, how do I know that this angle is equal to 60 degrees? How did I find out? Now, what you need to know, sum of angles in a triangle, angles in a triangle is equal to 180 degrees. Meaning, if I've got angle A, I find angle B plus angle C, I must get 180 degrees. So when you add that angle and that angle and that angle, but since they are equal, we can say 3A, since A is equal to B, here angle A is equal to angle B, which is equal to angle C. Reason what? Equilateral triangle. So 3A is equal to 180 degrees. Or let's say this angle was X, this was X, this was X. Instead of saying A, you can say 3X here. If they say find X, you divide by 3 on both sides, and X then become 180 divided by 3, it becomes 60 degrees. That's why here we say X is 60, and here X is 60. So that's how you find that. And then for conditions of congruency is the last one. Okay, second of last is the conditions of congruency. Now the first one of congruency is, what does the word congruency mean? It means identical. So about congruency, look at this. If I've got this triangle similar to that triangle like that, and I got another one also doing the same thing like that, first condition of congruency is A, B, C, A, B, C. So if that side is equal to that side, this side is equal to that side, and this side is equal to this side, we call these angles congruency. It means side, side, side. That's the first one. The second one, you can have a triangle, two triangles which are congruent. Draw them like that. Doesn't matter how you draw them, but for them to become congruent, what will happen? If I've got A, B, C, I've got X, Y, Z, for example. Now look at this. If I've got that angle and that angle, if I've got this side and that side, if I've got this side and I've got this side, so it means these two triangles are congruency, meaning what? Side, angle, side. Are you with me? Moving on. The other says for conditions, I can have a similar situation like this. This triangle is like this, and this triangle is also like this. These are two triangles. Now look at this. They become congruent if this is my A, B, C, X, Y, Z. Now look at this. If I've got this angle and that angle, got this side and that side, got that angle and got that angle. So now look at this. They are congruent because there is an angle, then there is a side, and then there is an angle. Angle, side, angle, or angle, angle, side, or side, side, angle, angle. Doesn't matter how you name it. The last condition of congruency is when I've got a 90 degree like this. See, there is a 90 degree here, and I make also a similar angle, triangle, also with a 90 degree. Now look at this. Congruence here is 90 degree. You've got that side as well as the hypotenuse. So it's what? Here? It's 90 degrees hypotenuse, 90 degrees hypotenuse, and what? Side. So this is also another congruency. Now then, remember, congruency means identical. The last one is similarity. What do we know about similarity? Similarity means the angles are identical, but the sides are not identical. For example, if something is similar, you can talk about this. Look at this. I can have a triangle like this, right? Actually, let me make it like this, a different triangle. So I can have a triangle like this, and I can have another triangle like this. So what makes similarity come into play is, look at this. If this is A, let me do this here to say this is A, B, and C, and the other one, this is X, Y, and Z. Now look at this. What makes these congruent? That side will be equal to this side, and this angle is equal to that angle, and just to make it like that. And lastly, this angle is equal to that angle. So what are you getting? For congruency to be in place, it will be A is equal to angle X, B is equal to angle Z, and what? And of course, C is B is equal to angle Y in this case. Sorry about that. Angle Y, and C is equal to angle Z. That's congruency. Similarity. But what is it about similarity that you need to pick up? Very important. Now pay attention. If we are dealing with similarity, the only thing that they want you to compare is the sides. To say side AB over side XY. See, I'm comparing. For my AB, I've got XY is equal to side AC. Take side AC, it will be what? Divided by side what? XZ, which will be equal to side BC divided by side YZ. We call it proportionality. This is using proportion. That's when you talk about similarity. And the other properties of a triangle, think of it. If I have a triangle like this, and in that triangle, beside the angles in a triangle adding up to 180, if I've got A, B, C produced to D. Now look at this. That particular angle, we call it, let's call it 1. And there is something special with these two angles. It means C1 is equal to angle B plus angle A. Look at it. What is it called? It's called the exterior angle of a triangle. Don't forget that. So it doesn't matter how you do it. I can come up with another triangle. It can be like this. This is a triangle. But the moment I produce that line like that, it means that particular angle will be equal to the sum of these two angles. So if I know this one is A, B, and C produced to D, now look at this. If that is 1, C1 there is equal to A plus B. Why? It's the exterior. This is outside angle is equal to the opposite sum of the opposite interior angles. It doesn't matter how you draw it. So basically guys, I wanted to do this in 24 minutes. It might be a little bit more or less, whatever, but I've come to the end of this lesson, and I want you to always revert to this lesson every time you want to get hold of the general properties of a triangle. Apologies for the background noise now. It's done because of, you know, our load shedding issues and electricity just went, but that's why you see now I hear some sound in the background. But anyway, look guys, I'm rooting out for you. Go through these lessons, revise them. Don't forget to subscribe to our channel, and ensure the notification bell is turned on. I'm rooting for you. Good luck on your exams. Cheers. Bye.